Hi everyone. We're on the third lecture, third part of the respiratory system, and I'm on section 10.4. And there's some interesting things here. It's good background to read. Remember we said ventilation is what we call inspiration and expiration, or inhalation and exhalation. And it's talking here, it does kind of a little review, so you might want to look that over. So yeah, and so what you want to be aware of is the muscles that control breathing are not actually in the lungs themselves. That we have two major sets of muscles. One muscle is the diaphragm, and the others are the intercostal muscles which are the muscles between the ribs. And so, in order to take an inhalation or inspiration, same thing. Remember, air is coming in, and what has to happen is the space of the lungs is made larger. So the lungs are mostly made of those alveoli, this really thin, delicate tissue. There's not muscle in the lungs. But what happens is the diaphragm is a muscle that's right below the lungs. So the lungs actually kind of sit on the diaphragm. And I don't know if you can see that. I'm kind of going right here. It's kind of right here in your body. You can see how it cuts on the ribs right there. It's kind of right along the bottom of the ribs, and it goes all the way across your thoracic cavity. And so what happens is when you inhale, what causes inhalation is taking a breath in, and I'm pulling the diaphragm down. By that inhalation, your diaphragm is actually getting pulled down. And then there's kind of a nice little video in the virtual lab that shows you this process. The other thing that's happening is these intercostal muscles, so the muscles between your ribs, are also contracting. So we've got all this contracting going, but by contracting the diaphragm, contracting the intercostal muscles, you're actually making the thoracic cavity larger. And so the air is actually being drawn into the lungs. And that's what they're showing you here. And that's inspiration. So by making the lung cavity larger, the pressure in the lung spaces is lower. So air is going to move into the lungs. Then in expiration, the diaphragm relaxes. It's going to move up. The intercostal muscles relax. They're going to make the thoracic cavity smaller, and it's going to push air out of the lungs. So the lungs themselves are made of mostly of that simple squamous epithelium in the alveoli. The muscles to control breathing are surrounding the thoracic cavity. They're not actually in the lungs themselves. And that's what that all talks about. Let's see. So there's a couple of numbers that we can measure. Like if you are having a respiratory problem, there's a couple numbers that are really useful. And the volume that air that you naturally breathe in and out with every breath, your normal breath, you're just that volume that I breathed in and out is called the tidal volume, and that's about 500 mils. So think about your 2-liter bottle of soda. So a quarter of that is about what you breathe in and out at each breath, and we call that the tidal volume. The number that's probably the most important in evaluating the health of your lungs is a number called vital capacity. And the vital capacity it says the maximum amount of air that can be moved plus the maximum amount the maximum amount of air that can be moved in plus the maximum amount of air that can be moved out during a single breath. It's called vital capacity. So if you were going to measure your vital capacity, you would first take the deepest breath you can, and then you would breathe all of that out. And there's actually a piece of equipment called a respirometer where you can measure that vital capacity. So if we were to do this in lab, what I would ask you to do is take your absolute deep breath and then measure what's coming out. So I'm going to show you if I were to take a deep breath. That absolute maximum amount of volume of air that I can move out of my lungs would be equivalent to the vital capacity. And this graph is trying to show you that. Here's the volume you breathe in and out and in and out. And that's your That's your tidal volume showing you right here. But if I took a maximum inhalation and now we breathed out absolutely as much as you can, that's what we call vital capacity. And like I said, that's a great number to measure lung health. So if you have, respiratory disease, you might have your vital capacity measured to see if you're using a maximum amount. If you are very physically fit, you do a lot of aerobic exercise, you're young, things like that. You're a larger person, you're going to have a larger vital capacity. And so this is something, there are fancy respirometers, actually called spirometers, to measure vital capacity, but there's also some little handheld ones that we can use in the laboratory for like a teaching lab. So the other thing you're going to notice about vital capacity is the last measurement that I wanted to talk about with your lungs is what we call residual volume. So if we look at the vital capacity here, that's the amount of air, that you can move through your lungs. But even if you blow really hard, you can't blow all the air out of your lungs because that would collapse your lungs. It would collapse your trachea. And so we always have a little bit of air left in there, and that's called your residual volume. Okay, so your total lung capacity is your vital capacity plus your residual volume. And I'm going to mention this residual volume as we talk about emphysema a little in another video. But the thing I want to point out is, in order to exhale, having all those little alveoli with the air in them, so the alveoli in our lungs just have to squeeze about that much, a very small amount to get all the air out of them. If your lungs were just large, empty spaces, you'd have to push it a lot bigger movement to push all the air out of your lungs. So again, the design of the lungs, that it's made by millions of tiny little spaces instead of one big space, makes it a lot easier to push air out of them. I'm going to stop right there.